it's our community, welcome. Today we're from outer space, and Joe Wright is our guest. He is the operations manager for the Warkoshevsky Observatory at the University of Missouri at Kansas City. And he is also a member of the Astronomical Society, going to be president.
Vice
President of the Astronomical Society of Kansas City. And these are all people who gaze out into space on a regular basis.
Yes, thank you for having me here.
Well, you know, I noticed it's a pleasure to have you, but I noticed when I looked at your bio, you are not an astronomer, but an architectural engineer.
Yes, I studied architectural engineering and architecture at KU. And have worked in that type of field.
So what happened, Joe?
Well, of course, as a scout, or actually as a kid, space has always interested me. My dad was a mechanic at TWA and had a plane, and just found it fascinating standing in our backyard in Kansas City and looking up, and just got interested in it. And followed the path that many others have, especially if you go down to H. Bartle Scout Reservation near Osceola, Missouri, where it's really dark. You know, you work on the astronomy merit badge, and just sparked an interest, and just continued on throughout my adult life.
Well, I think the interesting point to be made here is that often a hobby turns into a career.
Yes.
And I think that's just terrific, because it's still a hobby with you as well as a career.
Right, and as we say, an unpaid career. There's a fine line nowadays between actually some amateurs and professionals. It's basically the only science where a true amateur can actually be a partner with professionals and contribute to the benefit and production of the science.
See, I just think that's terrific. Well, we have so many things to look at. We're going to get right to it, Joe.
All right.
And I want to talk about the meteor that fell in Russia. That probably is the most current of the news as far as anything falling from outer space.
If anything more could happen that day, it was quite interesting. We started off the day, everyone in the United States hearing the news and watching the video from the many dash cams that are prevalent over in Russia, to watch that bolide cross the sky when most of us were planning on hoping that the skies over Kansas City area would be clear, to watch the asteroid pass by, and all of a sudden here's this meteor. It's just, that's the way it goes.
I have a little statue in my office, and it's a man with a gun and a rabbit, and it says, "I went out to shoot a rabbit, and before me stood a bear." It happens to be Russian, actually. I bought it in Russia, but that reminds me of that, because they didn't figure on that one. That was a good size one.
And really it opened up people's eyes that had kind of forgotten that, you know, it's like billiards, 3D billiards in space, that stuff's floating around at tremendous speeds, passing through the solar system. Back in '94, some recall that a comet broke apart and hit Jupiter. Well,
and this one is a very small meteorite that is Russian.
Yes, that's Sikotia-Alin, piece of the Sikotia-Alin meteorite that fell in Russia years ago.
A long time ago?
Long time ago.
And the makeup of these meteorites is?
Well over 98% pure iron, then it falls off to the other trace elements, nickel, all the other components.
And it coalesces because it's traveling at such a great speed that it's literally in a molten state?
In space, they're traveling at huge speeds, and they could be any size. It's when do you stop calling a pebble, a stone, or a boulder? They're all different sizes.
But what makes them become so large? Is it so hot that they just kind of...
Some could be from impacts. Some are left over from the formation of the universe. Just pieces left over. It could be the typical meteor that you see in space, or see in the atmosphere. That streak of light is from something the size of a grain of sand to a piece of rice. The larger ones like this are meteorites.
And you brought a big one, and I thought, well, I'll just pick it up and show it, but that is really heavy. That weighs, what'd you tell me, 14 or 15 pounds?
14 pounds.
And it is solid iron, and you said that it has beginning to oxidize, so it's a little different color. But that is one big deal. Where'd you get that one?
This fell in Argentina. There's a few falls that are unwitnessed. When a meteorite actually is witnessed, it's called, you witness a fall. then, but most of the time we don't know them, that they have fallen, that people happen onto them. Like the Russian one you had earlier and this one here, there could be tons of it laying around that have been around for hundreds of years that, you know, finally at times get discovered.
So we just walk around with a magnet and guess what? You might find something.
Magnet, metal detector, it's unbelievable.
It is. Well, they make a pattern. I'm not sure whether you can see this, but this is, there it is. It's a cross-cut of a meteorite, and within it is a pattern because the iron molecules do make patterns. It's like crystals that make a pattern.
Yes. The pattern you're seeing is only in meteorites. There's no pattern like that on Earth. Meteorites.
Is it the same pattern in every meteorite?
Pretty much. I mean, there are some variations, but typically you'll see this woven pattern called the Whitman-Stanton pattern, Whitman-Stanton lines. There could be other random patterns, but a large percentage is, especially the iron ones, because they're common elements.
Well, the other interesting part of that little piece was that it's African, and it was found in around 1836. So that's been around in our little box for a long time.
Yes.
Well, I guess I have to ask you, because it's sort of confusing. What is the difference between a meteoroid, a meteor, and an asteroid? I never.
The meteoroid and meteorite are all related. In space, the rock is called a meteoroid. Like I said, it could be anywhere from a grain of sand up to larger pieces. When it goes through the atmosphere and makes the streak of light that you see, it could be traveling around 140,000 miles an hour when it enters Earth's atmosphere and starts to vaporize the outer layer.
Because it's hot.
Yes, it is when it's going through the atmosphere,
Yes, yeah.
but unlike a baking potato that could take an hour in a conventional oven, these things can fall to Earth after they slow down, free fall, in 3 minutes or so, let's say. So they do not have time to heat up internally to temperatures. The interior of these, especially the ones of this size,
The big one.
would still stay the temperature space, which could be near minus 454 degrees Fahrenheit. So unlike the movies, you can actually go and pick these up when they hit the ground. The asteroids, some have different compositions than the iron and stone meteorites. Some asteroids don't have a dense body like you would think that iron have. They can have more silica, more sand, more rock, unlike the iron meteorites. So, and they do vary. I mean, you could find one that's very dense, or you can find one that's loosely dense that is basically like pumice or something.
Well, that big meteorite is very dense.
Yes, this one here, yeah, being nearly pure iron.
Now, when you're talking about silica, we have all kinds of interesting things. This is basically silica, and where and what am I holding?
Commonly, it's called shock quartz. When you take sand, it's elemental glass.
Shock quartz?
Right. When a meteorite comes in or a large mass and impacts, the heat created can actually fuse together the soil or sand or whatever's in that area. This could be from the Gibeon Desert or the Middle East, where it actually fused the sand into glass, and that's a piece of it.
And we know that this is a sandy place because of the silica.
Right.
Didn't fall in a sandbox somewhere.
No,
Big sandbox.
Big sandbox.
Big sandbox. And these are kind of interesting things too. I have all kinds of, I have a whole handful of rocks here. These are not very heavy, very black, but not very heavy. So what am I holding here?
Those are called tektites. If you notice, they have a classical teardrop shape. You can imagine, especially if most people by now have been somewhere where they've thrown a rock into mud. And you know, a piece of that mud will fly back up. It'd be ejected back out and fall back down. Basically, that's what you're handling, is something fell from space, impacted the soil, fused it while it was still molten from the impact of the heat, because part of the impact gets transferred into heat energy. As that's falling back down, it starts to solidify into that teardrop shape, and that's why we have tektites.
Is this just trash from outer space?
Well,
What is this
you
stuff?
can think about the soil in the area of the impact site that's gone back up after the impact.
It's like when a raindrop hits a pool, it splashes back up?
Right.
Ah, Okay.
Well, actually, if you can go online and look at videos where they show the raindrops that you're talking about hitting dust, and the dust will fly back up and come
that's
back down.
the tektite is the same
Basically,
principle.
that's what it is.
Yeah.
The
Because they feel like oh, I don't know, pieces of charcoal. Maybe they're not very heavy.
right, and they don't have the density like the iron has
Right,
because it's made up of the surrounding soil structure that they were impacted. In fact, as you turn the one around in your left hand, on your right hand, you can see where little pieces of it have been broken off, and it reflects like black glass.
There it goes. There it goes. Yeah. Fascinating. Do you own any? Do you ever find anything wonderful? like
Haven't
that?
been fortunate enough. There are places still in the world that you can go. Meteor crater out in Winslow, Arizona, one of the United States' most famous impact sites. Picture a small house coming down and causing a hole about a mile wide and 600 feet deep that's ejected the soil around the area out into the canyons surrounding the area, and people can go out into the desert and
One
pick
big
up.
hole.
Yes.
Absolutely.
So that's,
You know, as if we didn't have enough to worry about here, do we have to worry about getting hit with a meteor?
yes.
Oh, good.
Well, I shouldn't say as an individual. There's very few, maybe one or two documented cases where maybe somebody has come close to being hit by a meteorite. One of the
Didn't I read just in the newspaper just recently that there's a meteor passing by, but it isn't going to hit?
It could be an asteroid coming by. I
Asteroid.
mean, it happens all the time. I shouldn't say all the time, quite frequently. In Peekskills, New York, and I believe it was in the 70s, there was a meteor that came through during the daytime or late evening where people at a football game actually videotaped it. One, I believe it was also a fragment of that, went through a car parked in the driveway. That
great.
weighed, I'm not sure, it was a little bit bigger than this, but a local university had bought it
Well, that
from
didn't
the
do
family.
any good for the car. I'm telling you, if that hit the car, that's one big heavy rock.
It passed through the trunk.
So the likelihood of getting hit with a meteor or an asteroid is not very likely.
Well, the likelihood of us actually being physically hit,
Yeah.
I'm not going to say we're not going to be hit by an asteroid. There's a lot of debris out there. It could be like billiards. Two of them might collide on differing, their orbits intersect, or a rogue passes through that we don't know about. When you think about looking through a telescope, imagine holding your outstretching your arm and putting your finger on the sky. And when we're looking at the sky, we're looking at areas smaller than your finger. And there's just so much sky and so few observatories trying to track meteors, not meteors, but asteroids. Right now, we're outnumbered. That
But
we need
I'm
more
not going to
observatories.
spend a lot of time worrying about this.
No.
I'm not going to do it.
Right now, we can't stop it, and so I'm not going to worry about it myself.
We'll just soldier on. This is an interesting one. This is a comet.
Yes.
And this photograph, talk about where this photograph and how it was taken.
I believe I took that in my backyard years ago in the mid-90s. We were fortunate to have two comets come through our solar system within a short period of time. Comet Hale-Bopp was one of them. It was one of these comets that you can go to in the evening watch, and it'd be up early in the morning. They were that slow.
What kind of camera did you use?
That one was used. I used a old Canon AE1 program, and it's probably about a 2-minute exposure.
And now people don't use those kind of cameras anymore.
No, it's all digital.
Well, I know that there is a plan for a new observatory that you would like to put forward, and your architectural engineering background comes in very handy with this. And where is this new observatory that you want to, you have a plan for it, and it's really pretty. It's all drawn out in nice colors. Where do you want to put that?
Well, it's our dream to have it within the Lewisburg area. There is a site south of the observatory now that could house it. We've outgrown Powell Observatory.
Well, now this one has a couple of telescopes in it.
Yes.
Big ones.
We'll keep our 30-inch Rusinger telescope, which is basically an image of it on the left. Then our desire would be to have a larger telescope, excuse me, about 1 meter in diameter.
And
That,
it would,
about 1.3 meters in diameter, and with a planetarium on the property.
so you can see more and closer up.
Right. One of the things we want to do is actually partner with University of Missouri, Kansas City, KU, Johnson County Community College, William Jewell, Longview, and some of the others, and start doing research at the facility. With something around 1.3 meters, they might not have to go, they won't have to go to Texas or Arizona. You know, they can actually start doing research here and maybe do more of it because of the cost would be lower.
Terrific. Well, we'll look forward to that. In the meanwhile, we have a lot of really interesting pictures and photographs that you have brought. So we are looking now at the sun.
Yes, this was a picture taken through a small, actually about a 4-inch telescope using just a handheld digital camera.
And you can see the sunspots even.
Right, there's several sunspot groups, about 4 on that one, especially with the larger one there pictured to the lower left. And sunspots are basically areas where the magnetic field is very high. And the sun rotates differentially, in other words, at different rates as you go from the equator towards the poles. This winding of the field lines starts to loop out off the sun and rise up. And they go from the positive to the negative side of the sunspots. And sometimes you'll see a solar prominence, which is the loop that comes off the sun.
So when the positives to the negatives hit, then something flies up, and it's often those eruptions that we see on this.
Yes.
Good.
Basically.
And then we all can pick out Jupiter.
Yes. The king of our solar system as far as planets is concerned. The sun takes up 99% of the mass. Jupiter's the next biggest thing. On good evenings at the Borkachevsky or POW, excuse me, that's not uncommon like the image you will get through the telescope.
Really?
Yes.
So, well, see, and all the more interest to people who want to come out and take a look.
Yeah, there's at UMKC the 16-inch scope's one of the sweetest ones in the Kansas City area for planetary, and on a routine basis we actually see the great red spot.
Okay. We then have some more that you brought. You brought some interesting, and this is beautiful. What is this?
That is the great Hercules star cluster, also known as M13. This is a globular clusters are some of the oldest objects in the universe.
And these are all stars?
Those are all stars, anywhere from 300 to 500,000 that have a common gravitational center.
When you say a common gravitational center, are they swirling around that common center?
Very slowly. I mean, it takes hundreds of thousands of years, millions of years to go around, but they do have a common gravitational center, basically a snowball of stars.
I see. Okay, well, the reason that they hold their shape is they're not traveling so fast.
And the gravitational pull towards the center.
Yeah. Okay, and we can look at this. This looks like an eyeball.
That's the ring nebula, also called M57. As stars go through their life cycle, they expand and contract and give off some of the hydrogen gas, and that's the ring that has formed from it.
Is the red hydrogen?
All of it is. It's from different perspectives. Is that a tube or a ring that we're looking at?
We don't know.
We don't know, because if you're looking down a tube, it will look like a ring.
Yeah. Very, very interesting. And here are 3 old friends.
On the left is Mars, and you actually see the polar ice cap. Then in the center would be Jupiter.
And the polar ice cap, we're looking on the left at the red planet, which is Mars, and that little white cap on the top is ice.
Right, and back in 2003, when Mars was at its closest approach to Earth, the polar ice cap and the larger features that you see in dark on the picture were visible from down the telescope's to 8 inches in diameter.
And some of those are high, some of them are low, mountainous.
Yes.
Or, yeah. And what makes it red?
actually, there's a lot of iron in the soil on Mars.
Well, you know, we see, and it's really kind of interesting because sometimes when you travel around the United States, you see very red soil.
Yes.
So there's a lot of iron oxide in that soil.
Yes, especially in, I would believe in clay, there could be quite a bit of that
And we
in
call
the desert
that
Southwest.
rust.
Yes.
So the rust is what makes Mars red. And our old friend in the middle there,
Jupiter.
Jupiter, and he is the largest planet.
Yes, the thing about Jupiter that's nice to observe, that in a short period of time you can see changes. The rotation of Jupiter is just a little more than 9.5 hours, so in just a few hours of observing you can see a change in Jupiter. Plus the 4 larger moons, the Galilean moons around Jupiter, you can actually see go around Jupiter. And sometimes one of those moons will cast a shadow back onto Jupiter itself.
Well, I can see that if you're going to be astronomically inclined, you have to be ready to stay up at night.
Well, no, you can do quite a bit of daytime
Really?
with the sun and the moon.
But if you want to see the planets, you need to look at night?
Yes.
Yes, well.
Unfortunately.
Yes. And then there's Saturn. What causes the rings?
The rings are leftover debris from the formation of the planet that's been captured in its rotation around the planet. The rings are just hundreds of yards thick, but 50,000 miles tall. So they're the thinnest, tallest objects in the solar system.
Isn't that something? 50,000 miles
50,000 miles are tall. If you were
and
at
it
the
doesn't
equator.
look like that.
No.
It looks very thin.
Well, the thinness is only a few hundred yards, but the thickness at each end is about 50,000 miles.
Oh, so from end to end, it's 50,000 miles around. Yes.
Yeah.
Yes. But this is a particularly interesting picture because of how it was taken.
That was used just holding a digital camera up to the eyepiece of the telescope.
See, and I think that's so interesting because it shows you that you don't need, if you can borrow the telescope from UMKC and look through it, you can use your cell phone.
Cell phone cameras, and we do a lot of that at the observatories now, especially with the brighter objects like Jupiter, Saturn, and the moon. Are very easy to hold the telephone up to the eyepiece and snap a picture.
Well, see, you don't need a lot of expensive equipment to enjoy astronomy. That's really the whole point.
No,
and
you
we can
don't.
borrow yours at the observatory.
A pair of eyes and binoculars
That's right,
are great.
That's right. You know, everybody is always so fascinated with the moon. And I think that, you know, we used to say it was made of green cheese and all that kind of business. But these, you know, the telescopes are so powerful now that we can see not only the depressions on the moon, we can see them up close.
The craters, the moon is a fascinating object. Your household binoculars are a great tool to use to look at the moon, and the telescopes are fabulous. We like looking at the moon when it's in its phases because the shadow line called the terminator will actually help us perceive depth when we're looking at the craters.
Does the shadow line show on this picture?
No, the shadow, the lines we see are pretty much made from the eyepiece.
Explain that to me.
Well, I'm shooting through the eyepiece,
oh,
so
I
I'm
see,
getting
I see.
the
I see.
vignetting
So
from the eyepiece.
the shadow is the eyepiece.
Right.
Reflect. Oh, I see. I see.
The shadow line I'm talking about when you look at a moon in half phase or something,
Oh, I see.
where it makes that delineation between the light side and the dark side.
I see. I see. What is your favorite thing to look at through the telescope? What's you find your favorite and/or the most interesting?
One of the ones that we haven't pictured is the Orion Nebula. Stars are made out of hydrogen gas. In the belt in the sword of Orion, there's an area of gas that's called the Orion Nebula, where the youngest stars are being formed. These stars are, 50,000 years old, so it's a nursery of stars. And just to look through an eyepiece and see that wispy gas 1,500 light years away, and knowing that those stars were formed long before that, but that light took 1,500 years to get to my eye. So from the romantic side of it, when we look through a telescope, we're looking back in time. When we look at the Andromeda Galaxy, another great object, we have to remember we're looking outside our galaxy to another galaxy that the light took 2.5 million years to get here.
So things are happening there that we can't see for another, what, 50,000?
Oh yeah.
Yeah.
If you think about it, we don't see the light from the sun until 8 minutes after it's left the sun. So
Long
it's
way
all
away.
about looking in the
Long way
past.
away. Do you believe that in your lifetime we will be able to be space travelers?
I hope so. To me, there's inherent eagerness in all of us, in mankind. If we didn't, we'd still be in the cave, writing on the wall, instead of walking out to see what's on the other side of the river or the hill. I hope America does get back in, or mankind actually, into space travel.
Well, you know, we're all, one of the attributes of humans is curiosity. So maybe that will allow us to become space travelers. I'm not sure that in my lifetime I will see that, and I don't know. I kind of like my feet flat on the ground, but I know that there's a whole worlds out there, and perhaps other planets with life as well. So, you know, the Powell Observatory is a most interesting place, and I think that now tell where it is and how one can visit it.
It's in Lewis Young Park. It's in Lewisburg, Kansas. You can go to our website, askc.org, and there are maps to both observatories, Powell and Vorkachevsky. The Vorkachevsky, or we call Warco for short, is open every Friday night. It's on the campus of UMKC at 52nd Rock Hill Road.
Everybody's welcome.
Everybody's welcome on clear Friday nights. We have a variety of telescopes up there. We are in light polluted skies, but we do a great job of looking at the solar system objects and some of the deep sky like we showed here today. Powell Observatory is, like I said, in Lewisburg, Kansas. The park is just northwest of town, and it's a 45-minute drive from the center of Kansas City.
So there are two opportunities, and you can set the telescope for whatever you are going to see in the night sky, and I think that's terrific. I think that we can also show the sunspots erupting. I think you brought a picture of the sun with the sunspots erupting as well.
Yes, at both observatories we have a special scope. What you're seeing is the sun through what's called a hydrogen alpha filter, and these particular scopes are called PSTs, personal solar telescopes. So if you can imagine that when you see a rainbow, the light is made up of different wavelengths. You can imagine that we're looking at light through a particular wavelength in the hydrogen range. And what you're seeing here is that loop I talked about coming off the sun, where the plasma from the rotation and the bending and wrapping of the magnetic field lines have wrapped up. Like if you took a wire or cord in your hand and twisted it, it would loop up. That's the same thing that's happening on the sun.
But isn't it interesting the opportunities that lay before us if we take the trouble to bring ourselves to them and invest some of our time and our energy and our interest in that. The Warco telescope, the Vorkachevsky Observatory at UMKC, and the Powell Observatory is in Lewisburg.
Yes.
All kinds of opportunities. Go and visit Joe. He's all about, and the Astronomical Society is very active. Lots of good people in there that will teach you and help us all to learn something that we did not know before, and that widens our horizons and opens up the universe. Thank you, Joe.
Thank you very much.
Joseph Wright, the operations manager for the Vorkachevsky, that's hard to say,
Yes,
Joe,
it is.
the Vorkachevsky Observatory at UMKC and the Powell Observatory at Lewisburg. Thank you so much, Joe.
Thank you very much for having
And
me today.
thank you. It's been a real pleasure. It's our community.